Hey, everybody.
Good morning.
Hey, Leroy, how are you?
Good.
Good
That's
morning, guys.
Hi, Karen. How was everybody's tea day? Hey, Amber.
uneventful.
Uneventful. Well, maybe that's what we want this year. Enough of the crises and drama in our lives.
Well, me and my entire family are vegetarian, so
Ah,
everything is not really our thing.
yeah. Well, did you have torfuku or whatever it is called?
No.
Just veggies?
Actually, we didn't do anything this year because of the pandemic.
Mm, well, nothing even like sweet potatoes or green bean casserole or stuffed mushrooms.
No. Well, my parents, like me, are vegetarians. My sister usually comes over, or we all go to my uncle's house in New Jersey. But because of the pandemic, everyone stayed home and we didn't get together or anything. So we didn't have a family dinner.
Sad as it is. Oh well. Hang on, Leroy. Let's hope. Let's hope. The vaccine is on its way. We'll see. All right, guys. Let's get going here. I'm glad everybody found the link. I don't know what happened last week. Something happened. Okay, so we have 3 classes left, including the one today. And I thought, since you don't need to worry about taking any more quizzes, we can talk about something that's not covered in the textbook, but something that is interesting and important. At least I like it. So I decided to talk a little bit about intelligence today. If we get a chance, we'll also talk about expertise, which is a part of the chapter 11 on problem solving. On Thursday, we will continue with chapter 12. It's one of the most difficult ones, so it's good that it's a Thursday. Most of you should be here. And this is going to be after you submit your lab 3, so less of a pressure to skip the class. Next Tuesday is our last class, so we'll talk about some conclusions to the course. Hopefully it was useful to you in one way or another. Maybe if you guys have questions about your progression in the program. I know some of you, like Karen, are already graduating, but others probably not. Or just about anything that we want to chat with. What else? As always, you will receive, or you probably have received already, a link to do the evaluations. Again, remember that evaluations is your own way, maybe the only way to change the way your courses are taught. So I, of course, would appreciate if you go and do it. Hopefully you can say 1 or 2 good words about the class. But also if you have suggestions, there is a field for your comments. Once the semester is over, we receive your evaluations. Of course, they're anonymous. We don't know who did what. but it helps us tweak the course so it gets better with every iteration. It's especially important for our younger colleagues, but it's also important for us. So do that if you can, um, especially if you like the course, or at least you were okay with that. And so you can, that's your way perhaps of saying thank you and moving on to the next semester. All right, so once I get your lab 3 texts, which is going to happen the day after tomorrow, over the weekend, I probably will start grading. So it's going to take me 10 days to a week to finish. So hopefully I'll have your grades by the end of next week. So sometime around December 13th. Goody. If you have any questions about Lab 3, I welcome them, especially if they are clarification questions. These are the easiest for me to handle. Please don't forget to send me uh, an invitation to your final Google Doc. Actually, we probably should look at it now, because one of the things you'll be doing for the remainder of the time is evaluating your group performance. And I need to hear that because your group grade may change depending on how the two of you worked, or three in case of one group, worked together. So, Karen, is that okay if I show your Google Doc so I can explain the document history?
Sure. Do you have the newest one? I believe I shared it with you.
Yeah, the one that you sent yesterday. I have it.
Okay, perfect. Great.
Is it okay?
Yes, of course.
Okay, great. Thank you. So Karen and Raphael, very generous in allowing me to show you how they handle that. So let me see where that is. Okay, good. Let's go back and share that part of the screen. Okay. It's going to be a little small, but that doesn't matter, because all I want you is to see how you would work with that. Okay, so here is the Google Doc that Raphael and Karen created for their Lab 3. And I'm going to go back, I guess, to see if I can start from the beginning. Okay, so this is what it looks like when you open it. You get, the first page. Your Google Doc may be longer than this one if you had other work here. Doesn't matter. So here you're going to go into File. And in File, if you go down a little bit, you're going to get version history. Right? Now, if you didn't name previous versions, it's not a problem. But what you can do is you can see version history. So if I click here, right, what you will see on the right is the history of working on this document. So for this particular one, Karen and Raphael worked on it from November 23rd. There is nothing before that. So if it were a document that you continue throughout the semester, you'll have more stuff. Note, can you guys see? Just to make sure that I'm not talking into the void. Rebecca, can you see the panel on the right? Parker, Amr? Yeah, okay, good. Everybody can see that. So on the right, in that panel called View History, right at the top, it shows you the times when the group members worked on the document. get something, annotation tool. Maybe change it back to pink. All right, so the current version that I'm viewing right now is the one from yesterday. Okay, so this is November 30th. Then there were 2 iterations of work on Wednesday, and 1, 2, 3, 4, 5 last week. Well, Wednesday, not Wednesday. It's yeah, it is a Wednesday, right? What you can see is the members of the group colored in different colors. So here is Karen is in green, right? And Raphael is in, what is that? Purple? No, it's not purple, lilac maybe. All right. Okay, so the final person who created this or edited this current version was Raphael, and he did that yesterday. So I'm gonna get rid of this. So let's see how it all started. So if we click on the first one, November 23rd, you can see all of that in green, which means this was Karen's work, all in green. This is a template for the lab. As you can see, there is just some words. They don't, just as pig Latin, so to speak, right? So they created a template. Karen did that. Then a little bit later, you will see that she started changing things. So got rid of all of the template pieces and started actually creating the stuff that would go into the text, right? So Karen continues to work. Next day, you can see a lot of the scratched out, taken out stuff is gone. Now we have the actual text. And this is what Karen wrote, because it's in green, so it's her contribution. All right. The stuff in black is from the previous version. Okay. So we can see that this is a lot of Karen's work. And now Raphael kicks in, and his contribution is going to be in purple, I guess, purple or lilac, whatever. So he hasn't changed anything here, but he started working on the results. All right, that says all, whatever you see in purple, and you can see if you hover your mouse over it, it will show you who was the author of this particular section. Now, 3 hours later, okay, I'm gonna go down and we'll see that whether there is more. Okay, the contribution and so on. So you can continue doing that and you will see green and purple. If by any chance you have a third person like one of the groups, you'll have 3 colors. So you can use that to assess how the 2 of you worked on this document. So what I will ask you to do for the form that you will fill out for your group work is to do some kind of assessment of how the 2 of you worked on your 3 labs reports, not just this one, but all 3 of them. The easiest thing would be to say that it was 50-50. If that was the case, then the grade that you will get is going to be the same for both of you. But if there were some issues, you will have to be more specific what you mean by this. Or if somebody was really above and beyond the work and actually assumed the leadership, then this person's grade for the labs will go up. So you need to be honest. That's one of the reasons why students find group work so hard, is because everybody wants to be polite. Nobody wants to say the truth. Now, but remember, the group evaluation form is confidential. It's for my eyes only. I'm not going to share it with anybody else. So I need you to be honest. Of course, if you had issues with your partner, you should have discussed and taken care of it long ago, but sometimes it's not possible. Okay, so you got the idea, right? So you're going to go, let me just repeat that step again. You're going to go into File, View History, see Version History, and then you're going to get the whole thing. You can do it for each individual lab, so you can do it for all three of them, whatever is the easiest for you. Because remember, I have no way of knowing how your group work went behind the scenes. It's up to you. Thank you, Karen, for sharing with us. It was, yeah, I will post it tomorrow. I just have to add another question to that. Okay, so far so good. Let's go back to what we're doing today. All right, so we are going to talk about intelligence mostly. Maybe if we get time, we'll talk about expertise as well. All right, so of course, in general, people may not be stupid, right? But as we know, some people appear to be smarter than others. And we have always been, as psychologists, interested in the individual differences in intelligence. And this interest goes back to more than 100 years ago. So there are some general questions. I mean, how do we measure these differences in intelligence? A more fundamental question is, what is the nature of intelligence? And, if there is some individual differences, I mean, where do they come from? So these are the sort of the questions that frame the work on intelligence in general. So let's talk about, oh, why isn't it doing this? Okay, I need to push this button. Okay, so let's think about this controversy. Perhaps you guys are probably too young to ever have heard about it, but in 1994, a well-known sort of journalist slash scientist, Charles Murray, and his colleague wrote a book and published it called The Bell Curve. Now, the bell curve is a well-known notion that comes actually from the research on intelligence. It's interesting, but I'm sure you have heard about it, where there's a distribution of something, usually scores in our case of for intelligence, where most people will fall right in the middle. And the reason why it is bell curve is called a normal distribution, because the three central tendency measures, which is mean, medium, and mode, all coincide in the normal distribution, which means if you are right at that point, let's say we'll take a median, half of the scores will fall to the right from it, half of the scores will fall to the left from it. Now, of course, you need to have larger numbers. Normal curves are very hard to achieve in smaller distributions. So anyway, the idea behind the book was to look at intelligence from the point of view of normal distribution. And I'll get to the questions in a second. There was a very controversial idea that scores on intelligence are normally distributed. That is, we will have a large, actually 68% of the people falling within one standard deviation of that mean, mode, or median, 96% falling within the two standard deviations, and 99.3, I think, or 0.1 fall within 3. So what's left is these tiny little tails on the right, which is people very are highly intelligent, and a very small number of people, less than a point, with very low intelligence. Um, Somebody that we would normally call, uh, you know, intellectually uh, disabled, something like that. So, an interesting idea, but perhaps a bit controversial. So, the American Psychological Association, which you know familiar with because of the APA style, tasked a group of psychologists, actually a pretty large one, to write a response to the book. And here is that response. It was the task force was led by Ulrich Nieser, one of the leading cognitive psychologists at the time. Unfortunately, he passed away not long ago, and a few other psychologists who had done some work on intelligence. So this is the article that they wrote called Intelligence, Knowns and Unknowns, published in American Psychologist, um, available online if you're interested. So this is what they grappled with when they looked at Murray's and Herrnstein's book on the bell curve. And I'm curious to see what you guys think. So these are the four questions, and what we will do, we will do our usual little poll. So go to participant manager. Let me just make sure that I open it up a little bit for myself. Okay, here we go. So let's look at the first question, which is, are IQ tests accurate measures of intelligence? I'm asking about your opinion. So if you think yes, then click the green button. If you think no, then click the red button. All right. Most of you think that it's not the case. Can can somebody explain your position? That that's not about right or wrong. It's about thinking about these questions. Julia, would you be willing to tell us what you think? Why you think this is not a good measure? Okay, you can just click the line where say last edited. Okay, good, it will work. Yeah, Justin tells us what we can do with Google Docs, but I'm interested in somebody's opinion. Most of you said no, those who voted.
It's
Okay,
very culturally biased.
the IQ tests, you mean, right?
Yes.
Mm-hmm. Okay. Anybody else who has an opinion? Oh, Amr says there are different types of intelligence. Okay. Mm-hmm. But don't you think intelligence has to do with actually being smart as opposed to being emotionally attuned? I consider that too, Leroy, but I also was wondering about IQ tests that are like puzzles that aren't cultural biased. It's quite difficult to imagine that you could measure a person's overall intelligence. Too many factors. Okay, interesting. Okay, good. Let's move on. Let me clear this. True. Let's move to the second question. What do you think? Is IQ a strong predictor of success in life? So click yes if you think so, click no if you don't think so. Mm-hmm. Good. Good. All right. 5 people think yes, and one person disagrees with that. Who is willing to give us a little bit of a, perhaps you have an example from your own life where being smart actually contributed to your success? Or um, maybe the other way around, unfortunately. Well, if you think that true, that question two is true, it must be based on some previous experience, right? I'm disagreeing here. Sometimes people are born rich or get really lucky. And you think that that will lead to success in life, Parker, right? Being rich may not be accurate, but it's still approximate. hmm Does anybody have any examples from your personal experience? Well, I think about famous scientists who have high IQs like Einstein. Yeah. Okay, Elmer, it's a little bit of an outlier, right? Somebody like Einstein. But in general, you're right. A lot of professions or careers that we think about as successful, think about law, medicine, college or university professor, require a lot of education. And there is a very strong correlation between IQ and amount of education. And there is a reason why. Okay, good. Let's clear that. Let's move on to question three. Do you think IQ is highly heritable? That is, you inherited from your parents and your ancestors. Mm-hmm. Okay. We have three people who voted out of seven. Go on, guys. What do you think? Again, that's not really about being right or wrong. It's about what you think. Okay, good. Three people think it's heritable, that is, you inherited, and two people think no. So it's a bit of a half and half. Here we do have some evidence that inheriting IQ is actually true. There is, of course, a contribution of the environment, but a large portion of IQ is indeed heritable. But again, that's not your destiny. Your destiny can be changed hmm by a psychosocial. Good. So half and half. Very good. Let's do the last one. Yeah, okay. No problem. Is IQ influenced by sociocultural factors? That is the society you brought in. hmm Good. That's the nurture component. Uh, okay, good. Perfect. Move that. So these questions were answered by Murray and his colleague. Um, the first three were answered as yes, and the last one was answered as no. So they believed, and that's what they presented in the book, was that IQ tests are accurate measures of intelligence, that they do predict your success in life, and that they are highly heritable, or it is highly heritable. but the socio-cultural factors have less of a influence on IQ. So the task force led by Neisser tried to dispel some of these assertions from the book by looking at the actual research on intelligence. Okay, so we can think about the approach to intelligence from the days when it was just in its beginning from the 2 points of view, two different trends. One was what we would call elitist, that comes from elite, right? The other one was called egalitarian. So let's look at the first approaches to intelligence from this point of view. So Sir Francis Galton. Okay, let's see, you guys are my very best students. Does anybody remember what were the two other occasions in this class that we talked about Sir Francis Galton? What were these two occasions, or what were these topics that he contributed to beyond what I'm talking about today? I'm going to give you a few seconds to try to bring memory back from the beginning and the middle of the course. Okay, nobody? Leroy? Karen? Do you guys remember what Galton was famous for besides working on intelligence? This is what we will talk about today. No? Oh, too bad. The two other occasions that we talked about him, first one was when we talked about the biological basis of cognition. We talked about phrenology. Phrenology is a pseudoscience that had to do with bumps on the skull that were correlated supposedly with individual traits like fidelity or personality traits, if you wish. And Galton was one of the fathers of phrenology. The second time that we mentioned and talked about him was when we talked about imagery. So we had an exercise on imagery, imagining four situations with your eyes open, your eyes closed. So we did a questionnaire on vividness of imagination, and that's also Sir Francis Galton's work. So very productive, interesting early psychologist, right? So he wrote this. He actually was Charles Darwin's cousin, in case you guys ever get to do history and systems. You may want to uh, research him. So he got very interested in mental abilities and mental testing. Now remember that Darwin showed that the physical characteristics of animals, right, had been shaped by natural selection, right? That's the natural selection theory, especially as species adapted to their environment. And Galton decided to extend this idea to mental characteristics. So in one of his works, it's an earlier one from 1869, he actually argued that intellectual distinction passed through families, right? Remember the hereditary approach to intelligence. Of course, 1869, there is no idea of genes. Genes were discovered much later. But he was convinced that individual differences in mental abilities are hereditary or heritable, if you want to say. But he was convinced that also that natural selection, the way Darwin presented it in his theory, would value high capacity. So if you are highly intellectually able, so to speak, right, you would be more likely to pass on your genes the way we talk about it nowadays into the future to your offspring. So he was a father of anthropometrics. The anthropometrics is a science of measuring people's mental and physical characteristics. And he actually had a station, one of the first sort of psychological, we don't even talk about psychology yet, in 1869. Remember, this is 1880. Wilhelm Wundt's lab in Leipzig in Germany. That was the actual first psychology lab. But he had a station at the South Kensington Museum in London where anybody could come and get measured if they were interested. And that was a little bit later than 1869. I think it was like 1883. He also had a student and a colleague, and perhaps his name is well known to you. It's Carl Pearson, and Carl Pearson is the person that who is whose name is associated with one of the correlational coefficients, Pearson R. So Pearson worked with this correlation coefficient to see if some of these traits, mental traits, are associated with others. Okay. Unfortunately, and now we can say unfortunately because we're looking from a point of view of 170 years later. He also founded the eugenics movement. Does anybody know what eugenics is? No?
Wasn't that something Hitler was like very fond of?
Hmm. Well, Eugene, like a name, right, is a Greek root that means noble. So eugenics movement meant that only people who are noble, so to speak, right, are the ones who should be, uh, living and uh, having children, and those who are not noble, but the word noble is understood in a much more broader way than just being from a higher class. It actually includes the mental capacities as well. So for Galton, it was, and for the eugenics movement, only highly intellectual people should be able to live and have children. So they argued for selective breeding and for people who have high intellectual abilities, and no breeding, sterilization, neutering of people who have low levels of ability. And we still have some proponents of this eugenics approach today.
As I was saying, that's something Hitler would kind of did.
Mm-hmm. Good, good. All right, so that's the elitist approach to intelligence, the very first one. A more egalitarian, that means equal, approach was proposed by French psychologists across the pond, English Channel in France. Uh, there was a big movement for open public education for all qualified children in France. But it was clear to the authorities that not every single child will be able to sort of profit from education. So they needed to come up with the ways of testing the children and see which ones will do well and which ones needed what we would call special education today. Now, of course, this kind of approach has to be objective, right? So it should not be contaminated by child's race or child's age. Not age is not a good example. Ethnicity, perhaps. So they needed a test. So they asked Alfred Binet, and that's Binet Simon test from 1905, to devise a test like this that will be based on the curriculum for the elementary school in France. And elementary school in France, just like in the United States, started at 5. So together with his colleague Theodule Simon, they created something that was known as Scale for Measuring Intelligence, and that was 1905 in France, right? Like I said. So this is how they structured it then, and then they uh, originally started with 30 items that were like samples of the kinds of activities children were taught in grades, in the kindergarten, first grade, up to the third grade. Okay. A little bit later, 3 years later, actually in 1905, they created a different version. Uh, and I'll explain it in a second, where they had 60 items. So what were the sum of the items on this original Binet-Simon scale? So following a moving object with the eyes. You would think that's really strange. But remember, they started with 3-year-olds and went actually all the way up to 13-year-olds. And what they noticed that um, originally they arranged the items from the easiest to the hardest. So obviously, following a moving object with the eyes or comparing two lines of unequal length is easy, but defining abstract terms or using 3 nouns in a single sentence is difficult. So the idea was, if you test a child and the child passes some tests and then will fail some other tests, then those who fail earlier, right, are the ones who may be candidates not to be educated in the mainstream schools. And they may have to go to special ed programs, the way we would call them these days. But the problem is, I mean, how do you define the cut point? Where do you say, okay, this is below the normal intellectual ability? So what they did in this 1908 version of the scale for measuring intelligence, they grouped their items in clusters according to the age level of the children who normally would pass them. So if you take 100, 98 will pass. So for example, very young children can do the moving object and maybe finding a square of chocolate, and older children, but of course they may not be able to repeat a sentence with 15 words. Older children might be able to do so, and so on. So they developed norms for measuring intellectual abilities for each level. So levels were from 3 years of age up to 13. And then they could compare every individual child's performance to these norms in various groups. So what's interesting, various age bands, we would say. What's interesting that they could use this to measure what they call child's mental age versus chronological age. I mean, these are two different things, right? So let's say if you're a 5-year-old and they test you and you pass everything that 5-year-olds, all the tests of 5-year-olds, most 5-year-olds can pass, then your mental age is 5. But your chronological age is also 5. So you could then compare the two. And if you divide mental by chronological, right, you're going to get a 1. 5 divided by 5. And then you can multiply it by 100, and that's how you would get the standard 100 IQ and the standard deviation of 15. I'm not going into a lot of statistical details. Now imagine somebody has a mental age of 4, the same 5-year-old child. So now you divide 4 by 5, you're going to get 0.8. You multiply it by 100, you're going to get 80. So obviously 80 is below 100, so your intellectual capacity is lower than it should be for your chronological age. By the same token, you can have somebody who is also 5, but whose mental age is 6 because they can pass the tests for 6-year-olds. So 6 divided by 5 times 100, you get 120. So this child's intellectual capacity is going to be higher than his chronological age. Okay, so this idea, let's get to the next slide. the mental age, was also developed to what we know as an IQ today, intelligence quotient, by a German psychologist, William. Oops, there's a mistake here. Oops, why? Stop. Let me change that. Where are we? And then I'll come back to William Stern. Okay, good. Fix that. Okay, German psychologist William Stern, or Stern, as they would say, which allowed to continue to arrange items in increasing order of difficulty, and then they would be grouped according to what each age band, most of the children in each age band could pass, right? And then it has to be a majority of children. And he came up with this formula that IQ is the mental age divided by chronological age and multiplied by 100. Okay, so that's how one came up with this idea of um, getting an IQ as opposed to just intelligence. So now it appeared that you could actually measure children's intelligence. Now, this idea, this French approach, Binet Simon, was quickly adopted in the United States. So a Stanford-based psychologist, Louis Terman, translated first, of course it was in French, translated Binet Simon into English, American English, right? And that's how Stanford Binet Intelligence Scale was born in 1916. Still, it has been obviously changed in the past 100 years, but still widely used. Now, he was interested in using it to study what he was interested in, which was gifted children. Robert Yorkes, who was at Yale, decided to take because remember, this was for children, decided to take this test and adapt it to test intellectual capacities of recruits for the Army. Now, this is around First World War and a little bit after that. So he created two tests, one called Alpha. This was for the recruits who were literate, was people who could read and write, and Beta, and these were the recruits who could not read or write. And these two tests, by the time the Second War came about 20 years later, was redesigned to become what we now know as AFQT, which is Armed Forces Qualification Test. Now, those of you might have relatives or friends who enlisted, they had to take that. And there is obviously several components of the test, but you could, if you want, you can Google AFQT and take, let's say, a verbal test, which is a practice is only 15 questions, and see how you can do that. Can you pass and be enlisted? So obviously the Army wants to have the brightest, the most capable soldiers it can get. Perhaps what you know the most is, of course, David Wexler. And what Wexler did, he was actually from New York, from Bellevue Hospital. He developed what we now know as Wexler-Bellevue Intelligence Scale, which was used for any adult, not just recruits for the Army. So its abbreviation is Wexler Adult Intelligence Scale, WAIS. All right, and then he also, a little later, developed another version of child intelligence test called Wexler Intelligence Scale for Children, WISC. Now, if you're lucky enough, and we will offer yet again test and measurements, which is a 300 level course. I think it's 325, maybe. There you could spend some time learning about psychometric properties of the scales and how they are created and how they're normed, standardized, and so on and so forth. It's a very interesting method. Actually, if you become a psychometrician, that is somebody who specializes in tests, it's actually a very good psychological career that can pay well. Unfortunately, for most of such approaches, even a master's in psychology may be not enough. You may have to go and get a PsyD or a PhD. So here is the WISE, that the way we know it. Of course, it has been changed several times since the time it was published in 1939. You have two scales, really. Um, so there are 11 subscales, the way we call them, and the first 6 are verbal, the ones on the left, and then the remaining 5 are performance scales. Now, there is an interesting distinction between the two. So if you think about information, I mean, how much stuff do you know? Like, do you know facts from history, mathematics, whatever? Do you comprehend the text? Those of you, a few, who took me on my offer to do a reading comprehension experiment with my colleagues from McMaster in Canada, did exactly that. Your comprehension of English texts was tested in that. They did the memory span, and this is something that we do a lot when we want to measure people's working memory. Remember, working memory is something that allows us to retrieve information from long-term memory and then use it. Arithmetic, reasoning, the similarities, it's a very popular subtest, and of course, vocabulary. Now, performance scale doesn't really have to do with your knowledge. It has to do with how you can manipulate information. So again, think about working memory, right? You have to rearrange pictures in order the way the events occur, or you have to figure out how pictures should be completed. Block design, those of you who try the Raven's progressive matrices, one of your activities, saw that, and a bunch of other things. Okay. So now, not only the new tests have been developed in the US, but also new ways of qualifying intelligence, which is interesting. So following Stern's approach to the distinction between the mental age and the chronological age, this was for children, right? Something like this was applied to adults. Well, here's the problem. If you take that formula, so mental age divided by chronological age times 100, most adults, you'll be surprised, will actually be scoring kind of low on the IQ test. Because imagine that if you are getting older, right? If you are in your 60s, your chronological age is high, but your mental age might be a little lower, or the other way around. So it turns out it wasn't very useful way to do it as it's done for children, because children are still developing. So their intellectual capacity develops way into the teens and perhaps even early 20s, but not with adults. So what they did, they created an intelligence quotient, IQ, the way we understand it now for adults. The way you do that, again, if you haven't taken statistics yet, don't worry, you will. They took the raw scores and they converted them into z-scores. A very quick and dirty explanation, a simplification for z-scores is a way to bring together scores that come from different scales. So imagine that you are, no, what would be a good example? That somebody gives you a test where you score, when you do a Likert scale 1 to 7, and then there's another test where the Likert scale is 1 to 5. And they're different scales, so they're different questions. I mean, how do you bring the two together? Well, that's why z-scores were invented. So you're going to get it on a scale of z transformation where the numbers will be the same. So when they took the raw scores from Y scale, and that's ages 16 to 75. They converted them into z-scores, and with the mean of 100. Yes, take care, Justin. See you Thursday. And then with the standard deviation of 15. And that's how we finally, that's what you see in Murray's book. You see this bell curve. Now, remember, I told you that 66% of the people, that's this part, will be, so standard deviation is 15, right? Mean is 100. So here's our 100. Not very good. Plus 15 for the standard deviation. We will have 115. And minus 15 going left is going to give us 75. Okay, so 68.3% of the people fall in this range on the IQ scale. Now, those of you who have done, and I saw a couple, I haven't graded your last week's contributions to your blogs. A couple of people have done that, and the two that I saw were 102 on Raven's progressive matrix and 112. And as you can see, 102 and 112 are within these 68%, which is when most people are. But adding another 15, that is going to 130, right, on the right tail, and going down to 60, which is intellectual disability, because we have a threshold of intellectual disability around 75 to 80. Okay, then we're going to get 95.4% of all the people. Again, we're talking about large numbers. So in that sense, it's a very useful way to think about intelligence. All right, let's clear that. So think of that as a deviation Q. How far do you deviate from the mean? And this is, again, just a little example of how raw scores can be converted to what we now think about as IQ. So 40 on the raw scale would give us 100. 28 will give us 85, 52, 115, and so on, right? So it's a very simple z-score transformation. Z-score formula is very, very simple. One of the first things you'll learn if you haven't done so in 266. So if we look at sort of distribution of IQ scores, right? This is from many, many people who were tested. You can see that bell shape emerging. Oops, no, it's fine, right? Emerging right here. So very, very few people are in left tail of the distribution. We call this left tail, the stuff that goes to the left from the mean, and also approximately as fewer people in the right. So as you can see, right, technically you can imagine IQ to go way beyond 145. And we do have occasional geniuses whose IQ is off, as we call, off the charts. But as you can see, this is such a small percentage of people. But even 130, 2 standard deviations from the mean, is a very small number. And I mean, this is just a sample of people that were tested. Okay, so this is also known as Gaussian distribution, in case you've ever taken math and learned about functions. And as you can see how close this sort of stepwise distribution to the actual smoothed bell curve. All right, so anybody beyond 80 to 75 that is lower than that would be classified as and in those days they were classified as mentally retarded. Today, like I said, we call them people with intellectual disabilities. Of course, even by just simple nature of statistics, there will be some. I mean, if we have to have a normal distribution, we will just have some people who will be of low intellectual capacity, because otherwise there is no normal distribution. But also there are accidents, right? People are born with some traumatic experience, maybe fetal alcohol syndrome, and they will have low IQ just by chance, right? As opposed to, and that's exactly what, if we go back to Francis Galton's idea of sort of elitist approach to IQ, is precisely what he would expect. He would expect the IQ to be normally distributed in the population. Fewer people with high intellectual abilities, few people with low intellectual abilities. Interestingly, though, that, I mean, if you start thinking about it, um, it's um, it's a little bit artificial in a way. I don't know if I make sense, but think about this z-score transformation as opposed to taking raw scores. Um, it somehow creates, sort of forces us into this normal curve, although one could imagine in real life that we have more people with high intellectual ability, but then we will lose the normal distribution. So when this Army Forces qualification test was developed, a bunch of youth were actually administered that test. They were not necessarily people who would then continue to enlist, but just young folks. Oops, I'll show you that graph next. All right. So, and that was administered in 1980, so not that long ago. So what they found, and here's, you can see that this gray dotted line, these were the actual original scores. Now, if you look closely, you'll see that there is actually quite a large proportion of these people, these were young people, right, who actually scored okay. I mean, certainly it was normed differently. Because at that time, the mean was, actually, the mean was 50. So as you can see, that what we call, it's a right-tailed skewed distribution. So the more of these young people who were tested on this AFQT scored in the right tail, they were intellectually more advanced. Once they took these scores and converted them into a normal distribution, now you can see how, so let me clear that, right? Now you can see that a bunch of these people from this section here, right, actually got pushed into lower IQ scores when they were converted into um, z-scores. So if we think about the z-score and this deviation IQ and all of these statistical approaches, there is something to be said about it being artificial. And perhaps you guys might even experience that in your life if you ever got in a class where you were graded on a curve. Okay, and let's get rid of this. So anybody who is thinking of going to, grad school, for example, so Weiss, Wisk, and Stanford Binet are all normed and z-transformed using this mean of 100 and standard deviation of 15, as I showed you a second ago. But if you are planning on taking, many of you took SAT when you applied to college. Some of you may have to take GRE, not this year. Actually, CUNY this year decided not to not to require GRE for anybody who wants to apply to grad school. Today is the deadline for many graduate center programs for foreign students, not for you. So GRE is also standardized like this, with a mean of 500 and a standard deviation of 100. If you are interested in GMAT, this is the test people take for business school to get MBA. The same, just like GRE. LSAT, anybody who is interested in law school should know that its mean is 150. That's a transformed approach with standard deviation of 10. Okay, so also GMAT, that's a medical school test, I believe, is also works like this. So the idea is, even though if you're going to get people who are in the right tail that they are better, through this transformation, they will be pushed into the normal distribution, artificially making some of the highest scores as if they have lower scores. See what I mean? So it's an interesting statistical approach, beloved by law schools and business schools, because they need a way to quickly and dirtily, I don't know how to say it, in a dirty way, to classify applicants without spending a lot of time going through masses and masses of applications. So it's an easy way to supposedly, um, and as you can imagine, then some people will be pushed into this lower. Of course, we don't have a C minus at CSI, but you can imagine that if you are in that uh, situation, if you were perhaps somewhere in the middle of the pack, once they rescore you with a Z transformation, you may be pushed from this mean into the lower. So forcefully redistributing people from the skewed to the right to a normal distribution in the middle. Okay. Again, maybe some of you have experienced that in curving on the grading on the curve in some of your classes. All right, we'll take a little break soon. So let's talk about some of the properties of these psychometric tests. All right, so when you create a psychometric means it's a branch of psychology that does tests and measurements. So like I said, if you are interested in a really nice career that pays well, psychometrician is one of the ways to go. So when you create a test, and you be surprised how many tests have been created by psychologists. In fact, there is a publication called Yearly Book of Tests and Measurements. So a yearly, that is published every single year, that has all the tests that people have come up with. So if you are at some point in the need of a particular test, don't reinvent the wheel. Just find it, because all of these books are available in the library. So the first thing is you have to sort of standardize it. And remember, standardization has to do with making the test as objective as possible. So it treats all test takers equally, regardless of the race or ethnicity or cultural background. Of course, age is different because we have to look at children separately from adults. The next step, once it is standardized, is to create norms. And create norms means you have to run the test through samples of population, and you have to use special formulas to decide which samples, how big they are, and so on and so forth. And once you have the norms, which is important for any kind of clinical assessment or neuropsychological assessment, not only for children, but we have tests for scholastic aptitude, we have tests for memory norms, to make sure that we can detect people with mild cognitive impairment just before Alzheimer's sets in. Then, of course, it needs to be checked for reliability, and there's two types of reliability that are being tested, usually being not tested, but being checked. One of them has to do with inter-rater reliability. That is, if your test scores are scored by one psychologist and then by another, will the scores strongly correlate? And that's what inter-rater reliability means. There's also test retest reliability. So if you take the same test in a year from now, unless if you're a child, of course, then your scores should also be very close. And if that's not the case, then the test is not particularly good. The next one is validity. That means, does the test what it's supposed to do? That is, if somebody tests your IQ with using the measurement of your skull, remember phrenology? That's not a very high validity. Now, it has to really test your logic, your critical thinking, your problem solving, whatever we consider to be examples of intellectual activities. There's one final thing which is nice to have, but doesn't always happen, called utility. So really, really good tests are cheap to administer, are efficient, but have predictive value for other things in life. So IQ tests supposedly, right, will predict your your aptitude in college and your success in careers that require a lot of education. That is nice. Not every test has that because it's an expensive proposition to do it for every test. All right. What is it? It's 11:20. Let's take a break until 11:26.
Hi, Professor.
Yes, Isaac.
First of all, are we having any more tests?
No, you're done.
Okay. And a question about the report. Is the method the same as Myers?
To a certain degree. Can I, Leroy, are you with us?
Yes.
Would you mind answering Isaac's question?
What was the question? I didn't hear.
Listening. Isaac, can you please repeat your question?
If the method of our report is the same as Myers.
It's the same with minor differences.
Right.
Hold on. Let me pull up the email. We had a smaller number of pairs. We had 30 related, 30 unrelated, and 30 distractors with non-words.
Wait, so what do you say first? We have a smaller what?
A smaller number of pairs.
Pairs.
Our test used 30.
30 pairs.
Mm-hmm.
30 unrelated. 30 related pairs, 30 unrelated pairs, and 30 non-word pairs.
Well, pairs that had a non-word in them.
Right.
Right. Okay, let's get back to, you're welcome, to where we were. Oops.
Oh, Professor, yeah, I just want, so the stuff we're doing now, there isn't particularly a test on it.
No, there isn't. That's why I'm having fun, because I can talk about something that is not in a textbook, but something that I find interesting, and hopefully you find interesting as well. But you're not being tested on that, so you can relax. You can just think about it from the point of view of intellectual excitement. I don't know, Isaac, if you're excited by cognitive psychology. Definitely okay.
So basically, it's just the lab that's due and the extra points.
Yep, that's right. You're correct.
Professor?
Yes, go ahead.
So I was wondering how long did the experiment take? Was it 15 minutes? I actually forgot because it's been like 2 weeks since like I took the experiment.
I think it was about half hour to 40 minutes, depending how fast you clicked. It doesn't, I mean, that part is not going to be, not like I will see, oh, well, she didn't time herself. You know,
Yeah.
whatever it took. I'm more interested in you guys finally do the design correctly. That is independent variables. That's what you should have learned by now. So if you were still making errors there, then you lose a point. But if you say it was 50 minutes, but it was 30 minutes, I don't care.
Mhm. Okay.
But let's get back to intelligence. All right. So let's talk about, here's an issue, right? So how do you define intelligence? Now you need an operational definition. One could say, okay, intelligence is what intelligence tests measure. Then that's, you know, it's a very lame way of defining intelligence. So what happened simultaneously with the tests that being developed, like Weiss and Wisk, there were people who came up with theories of intelligence that has structure. So another perhaps statistician whose name you might have heard is Charles Spearman. That's also a Spearman rank order correlation coefficient called Rho, RHO, it's a Greek letter. So it's a different coefficient from Pearson, but similar idea. So for Spearman, he was actually a British psychologist, and he worked for a while together with Galton and Pearson. He noticed that some of the subtests on these IQ tests actually correlate with each other, right? So there are multiple intercorrelations among various tests and subtests. So so why do they correlate? That was his question. And what he decided to do, he decided to say that the reason why subtests correlate with each other is because there is common unitary concept that lies underneath all of them. And he called it G for general intelligence. But of course, you know, why then, if it is all about G, why isn't some of them then not perfectly correlated? That is, with a correlation coefficient of 1. Why is it the imperfect correlation? So then he said, okay, because there are some specific factors, right, that he designated as S here on the slide. And these specific factors, whatever they are, affect your performance on individual tests. So for example, if somebody gives you a question about, you know, paper folding, mental paper folding, you're doing it in your mind, but if you have to manipulate blocks, which some of the older tests had, and if you're clumsy, right, you're not very good, Rubik's Cube is not one of your favorite pastimes, you may not score well on this one, right? So because you're not particularly gifted for finger manipulations. So for Spearman, performance on any particular test would be this combination of general intelligence measured by G and those specific factors measured by S. Now, interestingly, a different position was taken by another American psychologist whose name is Thurstone. Again, this is all. Now, Thurstone came to the scene 40 years later than Spearman, and Spearman did not have the statistical tools that Thurstone already had 40 years later. So in this statistical tool is what we call factor analysis. And again, I'm not giving you any statistical details because it's not really that relevant. But the idea is that there are multiple factors, right? Using these factors, we can distinguish between primary mental abilities. And that was Thurstone's idea, that there are 7 of them. And some of them very well. All of them, I guess, are very easily understood. So, how do you deal with numbers? Your arithmetic. How many words do you know, and do you know their definitions? That's word fluency. Can you generate, I don't know, how many words can you generate in a particular category when you're given a minute? Do you know what these rare low frequency words mean? What is your memory, right? Can you reason? So all these things, and he called them primary mental abilities, right? So he did not, of course, deny general intelligence, because all these 7 tests on primary mental abilities also are correlated, right? But for him, for Thurstone, as opposed to Spearman, this idea of general intelligence G was rather weak compared to those specific factors. That's why he thinks the real ability lie. Okay? There's more of a story behind this Spearman versus Thurstone, but we won't get into that. The next interesting approach, it's even a more radical position. I don't know if anybody has ever heard his name. It's Guilford from 1967, who came up with a theory of the structure of intellect. Intellect, again, is your intellectual ability, where you would think of intelligence of being composed of a very large, original is 120, very large number of discrete abilities that can be represented here as a cube. So if you look at the color, if you look at the content, what you have here is these 5 types. So this figural, it has to do with physical features that you perceive through your sensory organs, right? If you see the tree is tall and another tree is short, right? It's also your ability to sort of manipulate symbols. Can you think abstractly? Another one has to do with you understanding the sort of words and sentences. What do they mean? Your reading comprehension. And finally, interestingly, something that will then become important a little bit later is your behavioral approach to things that, like social intelligence. Can you interact with other people? Then you can take the contents, these 4, and you can perform operations on them. So you, for example, can evaluate, is this tree longer or taller than the other one? And that's an easy kind of operation. We all do it all the time. The convergent production in his idea was solving different problems in the same way. So can you come up with rules that will allow you to do, the jug water problem that we talked about with Leroy last week, and Amr, actually, 3 of us. More interestingly, I think, is this divergent production, which probably is the base of creativity, the way we understand it today, where you can imagine that a particular problem can be solved in many different ways. And seeing these multiple different ways is good, not a bad thing, right? As opposed to convergent production. Then there's also memory, and boy, cognition here looks one small cube, but it's a huge thing. Finally, when you take the contents and perform operations with them, you're going to get what he calls products. Okay, you can get units of information, like simple facts. You can get classes, like categories. Again, we talked about that a couple of weeks ago. You can figure out the relationships between them and then put them all together in large systems like schooling, economics, so on and so forth. You may be able to draw some implications. So if you take these numbers, so this is 4 content types, 5 operations, and 6 products, you will get this magical number of 120. 120 intellectual abilities that each of them can, play a role in your intelligence. In fact, before he died, which I think was in the mid 80s, he managed to identify 98 tests that could test some of these cubes. Since then, in the past 40 years, other psychologists added another 20 cells, bringing this number to a total number 180. All right. Well, let's continue to the next one. Now, that's an interesting, the reason why I like talk about Raymond Cattell is because I actually use Cattell's culture fair test in many of my experiments. So note that Cattell is kind of similar to Spearman's. He embraced the general intelligence, G, but he also distinguished within that G two types. So he wasn't talking about specific factors, but he talked about that G itself can be classified as two things. So he called the first one fluid intelligence and second one crystallized intelligence. Now, fluid intelligence has to do with how you perceive relationships between various concepts and objects. And you may want to, find it if you do some neuropsychological evaluation, you'll see how that works out. Or if you do neuroimaging tests. And for him, it was important that fluid intelligence is not contaminated again by things like race and ethnicity. So it has to be culture fair. That's why Cattell's short test, and we will do one little example of that next. Cattell's test is all nonverbal. So it's in a way similar to Raven's progressive matrix, but continuously used even now. So fluid intelligence is something that is it helps you with your working memory versus so you can operate fast. So it's about perhaps processing speed. That's what you want to come up with something as a metaphor for this. Well, crystallized intelligence for him is product of experience. That is, it's your education, your life experience. And normally, this is what our standard IQ tests do. They assess our crystallized intelligence. The good thing is if you're interested in how the curve on intelligence operates sort of in our developmental perspective, what happens is as children grow, their IQ increases. Okay, who can guess at which age do we reach our peak intellectual capacity? It could be just a decade, or it could be mean age. Guess in the chat. Okay, Isaac says 28. Okay. Parker, 25. Okay, well, you guys are right. So what happens when you are between 30 and 40? What happens to your intellectual capacity? A drop. Yeah. Which one though, Parker? Fluid intelligence or crystallized intelligence? GF or GC? Fluid. Yes, Parker, exactly. So what happens as you grow older, and you guys are downhill now, soon be. As you grow older, your fluid intelligence it slows down, really. But your crystallized intelligence can actually be very stable or can even increase, at least as we know from work on linguistic capacity. We know Yes, Leroy, unfortunately. Your vocabulary continues to grow if you are in a relatively high career where you are exposed to new words and stuff like that. So crystallized intelligence in general stays pretty constant. It's your fluid intelligence that goes down the hill. And after 60, well, actually, let's say 65, that's really a precipitous change. So Cattell says that for our performance, intellectual performance, to be at its peak, we need both fluid intelligence, so we need to be fast, we need to have high levels of education, and we need to be motivated, which is what I have been trying to get you guys to do. Okay, so let's try. So Cattell's short, he's got several tests. He's got one that's called Short Culture Fair. Its full short version is 12 and a half minutes. We're not going to do that, not because we don't have time and we don't need to, but let's do one little test. I'm not going to see your scores, so don't panic. But it takes exactly 3 minutes. That is, it's timed, and it will have, I forgot how many, 13 items. So I'm going to stop the slideshow, and I want you to get your notebook or a sheet of paper, and I want you to write down numbers from 1 to 13 in the rows. So you can write letter answers for each of those. Okay, let me find the test. Okay, are you guys ready? Do you have your notebook and your pencil with you? So there's 6 of you. Okay, if you're ready, click on yes in participant manager. Okay, Parker is ready. Okay, Karen, Noor. Amber, Leroy, you guys ready? 30 seconds. Good. Leroy, what about you? I have issues with physically writing. Okay. Do you want to just type privately to me? So you'll have to type in one letter for each of the 13 of these answers. Okay. Amber, I need you to get a piece of paper and a pen or a pencil. And I'm waiting to hear from Isaac, who asked for 30 seconds. So Amber, are you ready? Isaac is ready? Okay, Amber is ready. Okay, perfect. Everybody's ready. So let me close this. So look at these 3 examples. I'm going to read you the instructions. Remember that the test has to be standardized, so you all have to hear the same instructions. So look at the first example. This is the first example. At the left, there are 4 boxes, 1, 2, 3, and 4. The last one is empty. Continuing along that row, you will see 6 more boxes marked A, B, C, D, E, and F. Of those 6 boxes, 1 will fit correctly into the empty box. Here, the little tree is bending over more and more in the first 3 pictures. Choose the correct box from over here on the right to go into the empty box. Who can give me the answer to that? Okay. Yes, the correct answer is C. All right, look at the second example. The black part comes down lower and lower each time. So at the next step, it would come more than halfway down. Okay. Yeah, good. The correct answer is A. No, wait a minute. Yes, correct answer is A. No, actually, I'm sorry. The correct answer is E. A is way too low. So that's the correct answer. Okay, goody. Now let's look at the third example. See, it's as if something is growing, right? Step by step. In the third box, there are 3. Okay, you guys are saying the correct answer is E. Perfect. Excellent. Good job. Clear. So you're ready. When I tell you to start, which will happen very soon, go on and do the rest yourself. So what I will do, I'll make it a little smaller to get the rest of the 5. There's 5 questions on this page, and then there is more on the next page. Now remember, you will only get 3 minutes. Begin with the first row just below the examples. So there's this row is right down there. I'm not showing it to you because I have to then start the timer. Now let me set the timer. Oops, wrong. There's my timer. There it is. Timer is going to be 3 minutes. So start with the first row just below the examples and work through this page and the next. So I'll have to, if you can, once you get to 5, say ready, then I'll wait for everybody and I'll move to the second page. Is that okay? In each row, choose just one of the boxes on the right, which would correctly go in the empty box, and mark it as your answer on your answer sheet that is on in your notebook, or for Leroy, I'm suggesting typing. But Leroy, type it in as a private message to me, okay? So it doesn't show to everybody. You may not have time to finish them all, but work as quickly, as carefully as you can. You may change your answer if you have to until I say stop. Okay, guys, so you're going to get 3 minutes, and I'm going to make it a little smaller. All right. Okay, go. Okay, remember you can change your answers if you think you messed up, but I need to see you say, ready, so I can go to the next page. I get Parker. Noor. Okay, I may have to, maybe a little bit of a delay for us, but don't worry, I will. That was supposed to be private. Okay, not a problem. Isaac, how many are there? 13. I'll move to the next page. Amr is ready. Isaac, are you ready? Okay, I'm gonna go to the next page where you will have the remaining 7. I have to make them even smaller. I'm gonna move from 6 so you can see number 12. I'm gonna move down so you can see number 13. That's it. Okay, do what you can, Parker, because we're not really doing it exactly how it should be done. Okay, I'm gonna give you another 30 seconds because I moved the page. Stop. Stop wherever you are. And now I'm going to give you the correct answers and you calculate your score. How many of those 13 questions you got right? So let me, are you ready? Okay, let's go back to page 1. Okay, 1, the correct answer is B. 2, the correct answer is C. 3, the correct answer is B. 4, correct answer is D. 5, the correct answer is E. Let's go to the next page. 6, correct answer is B. 7, correct answer is D. 8, correct answer is B. 9, correct answer is F. 10, correct answer is C. 11, correct answer is B. 12, correct answer is B. And 13, correct answer is E. All right. Well, first of all, you need to think, have you finished all 13 questions in, well, I gave you just a little bit extra time. Did anybody finish all 13, regardless of correct or incorrect? Okay. Did anybody finish 12? 11? Okay. So that's me. Okay, good. Perfect. So that's one of the problems, not problems, that's one of the design features of such tests. It's not that they cannot be done. They can be done if you have more time. The problem is that you're only given that amount of time, which is small. Now you can also calculate out of those that you did, how many of them were correct. Okay, no is also 11. Okay, good. Perfect. Let us finish with some modern approaches to intelligence. If anybody is interested in doing the full Cattell, you can talk to me. Now, one of the things that I suggested you might want to do is do Raven's progressive matrices. There are many different versions online. Not all of them are, well, those that are available online, not quite full Raven's progressive matrices, but they're good enough to give you an idea of your sort of intellectual abilities in general. Okay, and then these are some of the 3 activities that I have posted for you. Number 2, that's an interesting way of how were immigrants evaluated when they entered the Ellis Island before entering the United States in the early 20th century. There was an intellectual ability test that was given to them. What was it? How did they fare? And interestingly, we have some interesting research coming out of animal labs. What is the intellectual ability of animals? Can we actually come up with a universal test that would be useful, nonverbal, obviously, because they don't talk, especially primates? Is it even possible? So the new approaches, here's one of them. And again, I have one of the activities for you with Gardner's approach, a theory of multiple intelligences. And I think many of you thought about it when I gave you the original questions in the beginning of today's class. Is there one thing? Is it just general intelligence? But maybe it is more than that. So Gardner's idea is that intelligences are multiple. In his theory, which is relatively recent, right, about 40 years old, he distinguished 7 of those. So you can be very gifted verbally, like linguistically. I'm, for example, one of these people because I happen to know a bunch of languages. Maybe you're good at sort of logical thinking, maybe mathematics, or maybe you're good at directions and not even using GPS and still going north and south correctly. He was also very interested in, so this is the traditional, the first 3 are traditional ones that come from all the previous theories of intelligence that we've talked about. But he was himself an artist, and so he was very interested in including people who were artistically gifted. So he came up with another, somebody who is very good at writing music and maybe singing and doing anything that has to do with sort of rhythmic operations of the mind. He also was interested in athletes. I mean, we have many athletes who are, world class sportsmen. So they probably are bodily kinesthetic gifted. That's his ability, intelligence number 6. He also was the pioneer of coming up with these 2, number 6 and number 7. Interpersonal is the way you sort of think about yourself and you are gain access to your own internal life and evaluating it. And interpersonal obviously has to do with how you can interpret other people. And the evidence, again, I don't really have time to go into all the details, came from many case studies that he looked at. So, I mean, we do have people with brain damage. I mean, are they devoid of intellectual capacity? No, he said. Of course, we have very extreme cases like savants. If you have ever seen the Rain Man movie, that was one of the cases, right? Somebody who was extremely gifted when it came to mathematics and calendar, but was completely socially inept. So his evidence comes from many different sources. So that's one. Another one that, again, it's one of the activities that I posted for you is a triarchic theory of intelligence by Robert Sternberg. Okay. The Sternberg's sort of is based on his own experimental work, and he's still with us, but he's retired. Analytical intelligence, obviously, is what we've been talking about in intellectual IQ tests from the beginning of the lecture, something that you're very familiar with. Meta, M-E-T-A, means it's your ability to think about your ability to think. That is, can you sort of can you talk about how you do certain things, like how you use language, how you deal with problems? So it's above that. Meta means above, uh, outside of. Of course, it has performance component, that is processing speed. And then he was very curious about, for children, is how they acquire knowledge, and adults as well. But then he had the other 2 things that perhaps you guys were thinking about when we talked about whether IQ tests is an accurate way to measure intellectual capacity in the beginning. So creative intelligence, obviously, can you come up with something new when you are presented with a situation you're not familiar with? But also, can you quickly solve something that you're already familiar with? That is, do you have the automatization skills in tasks that are not new to you? And finally, the social intelligence or practical intelligence, something that we call street smarts versus book smarts, is whether you can adapt to a new situation whether you can change a situation that is not working for you, or whether you can remove yourself from the situation where you cannot do well. Okay, at this point, I expect to see you lab 3s and your invitations to your Google Docs, and I'll see you guys on Thursday, and the class is over.
Professor?
Go ahead, Isaac.
Yeah, I had another question. I forgot.
Yes.
How do I find the recorded lectures?
They are on YouTube. So what you have to do, you have to go to the weekly schedule. Do you have a minute, Isaac? I'll
Yeah.
show you. Okay, so let me get rid of this. Go back.
Have a great day and see you Thursday.
Yes, I see you Thursday. All right, where are we? Show all windows. Okay, Isaac, it's a little small, but can you see the blackboard?
Yeah.
So if you go to weekly schedule on the left, click on that. And then you have to go to the week that you want to get. So let's say I don't have today's lecture posted yet, but let's go to the one from last week. So this is November 24th, chapter 11. If you click on that, you're going to get the lecture right there. And all of them are available in their appropriate weeks, with some exceptions where we had like group work where people were in breakout rooms. Then I won't have that. But almost everything is on.
And this is what is Tuesday and Thursday?
Yeah. So if we go to, go to another one. Let's see, which one do we want to go on? Say concepts and knowledge. That's week. So lecture session 2. See, here is lecture and session. So here's the lecture November 17th. Here's session 2, November 19th. They are all on YouTube, but they are posted on Blackboard. Yeah, you okay?
Yeah, I think so.
You're welcome. See you
Professor?
Thursday then. Yes, Noor.
I have a question. So
Go ahead.
So for both of the research, they involved like the priming effect that you talked about, I remember in last class,
Mm-hmm.
where one word can influence the other word.
Uh-huh. Yep.
But you said just now that one of the words are the words in caps
Mm-hmm.
are the words that we have to determine if they were words or non-words.
Yeah. Mm-hmm.
In that case, how can it be priming effect if we're only looking at one word?
Well, you can't restrict yourself to looking at one word. You restrict yourself to making a lexical decision on one word, but you still see and read the other one, right?
Mm.
So that's the whole point. Will that priming from the other one affect your reaction time? And what happened, as you remember from your results, is when you have two unrelated words, there is no priming. That mean the lexical decision time is slower. When you have two words that are related, like nurse and doctor, then your reaction time is faster. So yes, you're not making a lexical decision task on the other string, but its presence affects your lexical decision on the second.
Mm. Okay, now I get it. I was a little bit confused about that because I was like, how can there be priming when we're only looking at one word?
Right. Imagine a situation, Noor, then where you were presented with just one word. So you see the word nurse on the screen. Yeah, so you're going to make a lexical decision, but that doesn't tell us anything. But the second word is there. You're reading it. You're just not making a task with it.
Oh, okay. Yeah.
That's why you have to have both. Because if you don't have both, then there is nothing you can talk about in terms of priming, right?
Mm. And for us, did we have to say that it was like yes or no, or word or non-word?
I think it was a word and non-word. It's the same as lexical decision. That's just different
And
terminology.
and for Myers, the other research group, did they have like the you said that they use the keys, right, on a keyboard.
They had a different well, obviously because it was 1971, but they had a slightly different approach, and we discussed that while you were not with us yet, but Isaac had the same question. In Meyer and Schranewald's article, they had to make a lexical decision on both strings. And the reason why they had to do that, so if both of the strings are words, you say yes. If one of them is non-word, you say no. But the reason why they did that, because they were looking at 5 conditions. They were looking at the remaining 3 conditions that I asked you not to look at, were non-words. So for them, it was critical that you have to do 2 lexical decisions. And what they showed, if you read the general discussion, you'll see that. What they showed was if you have a non-word compared to 2 words, you're going to be very fast. But we are not using non-words. So we're not using that part of their theory. So to have a double lexical decision test didn't make any sense for us. We are only testing one idea, whether there is a semantic network that allows some words to prime others if they are semantically related. That's why it's a semantic network. So one could say nurse and doctor are close enough that they will prime each other, but maybe a hospital and a hospital, maybe not a good example.
Water and like nurse. That was
Yeah,
like
well, these will be unrelated, so these won't even give us anything. But we need something that's further from nurse than the doctor. I don't know, bandage.
yeah.
So you would say that the doctor will prime nurse, it will be very fast. Bandage will also prime nurse, but it may not be as fast.
Mm.
We don't have this manipulation in our data because it would have been not a t-test.
Oh, and not in the other research study too.
Well, we're not looking at non-words. I had them in the filler, in the distractors, so that you don't get too bored with constantly saying yes, 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 yes. But they're irrelevant to this idea that related words are close to each other in the mental lexicon than unrelated words.
Mm.
Okay, guys, see you Thursday. Okay. Take care.
Thank you so much, Professor.
You're welcome.
Have a good day.
You too.
Bye.